Ladies and gentlemen, welcome back to the channel. Thank you so much for being here as always. Today we've got some more Cardano related content, which I know everyone really likes. And so today we've got Ryan and George from the Cardano Decentralized Exchange, or DEX, Cardax. We're going to be talking about what the project is first and foremost, but then also about a topic that everyone is really interested in, and that is sort of the how behind it, how all this works, especially around the issue of concurrency in the Cardano world. So Ryan, George, thank you so much for being here.
Thank you.
Thank you. Thank you, Hashoshi, for having us.
Excellent. Yeah, so right up front, I think it would be cool just to give everyone a little bit of background about yourselves to set the stage. So Ryan, do you want to go ahead and go first and give a quick intro?
Yeah, sure. So my name is Ryan Morrison. I'm the founder and the CEO in Cardax. Yeah, to give you a bit of an idea of how we started with Cardax was at the beginning of this year, was about the time when the Mary hard fork just had happened. So then for the first time it was really cool because you could start actually doing things on Cardano, moving from a research kind of a huge research project and so many white papers done by IOHK and partners as well. But until that moment, it was not really tangible, so to speak. So then, from March on, then you were able to create tokens on the Cardano blockchain, and then I started asking guys, as being part of for years of the Cardano ecosystem, I started asking in the forum of Cardano, just in chats, hey guys, do you know any? Now that the logical next step is kind of a Uniswap now on Cardano. So is anybody building this? What do you guys think of that? Would that be useful? And then I got a lot of feedback, created a Twitter account for Cardax, and the thing just took off from that moment on. And that's a bit of the story of how we started, by when and people started also saying that you should propose this on Project Catalyst. Also, by then, Catalyst was in had just finished Fund 2. So it was like the very early stage. So we also went about putting a proposal there, and we have won twice. So that's great also to get the support from the whole overall Cardano ecosystem, and seeing also then the big people waiting for something like this on Cardano.
Yeah, it gives you a lot of flexibility too, because you can be maybe a little bit more strategic around the token part and the economics of your protocol if you don't need to raise from other places, right? If you have some funding on hand, it helps to build things. Speaking of building things, and Ryan, thank you so much for that introduction. I think there was much ado, after the Mary hard fork, which gave us, the multi-asset ledger, the ability to actually do things with Cardano, like you mentioned. A lot of these projects started coming to life, and then with the early stages, or sort of the launch of Goguen and the basic smart contract functionality, everyone was expecting, okay, we're going to see dApps here very shortly, we're going to see DEXs and all sorts of things. And then the topic of concurrency came up, right, as a concern around the scalability of DEXs on Cardano as a result of the UTXO, or unspent transaction output model, that Cardano employs. I have a feeling, George, you're going to want to take this one, but I really wanted to talk through the way that you at Cardax are solving this problem, because of course on the show I like to highlight different solutions to the same problem, because there are many solutions to the same problem. So quickly give an intro to who you are and what your role is at the project, and then maybe we can roll into the solution.
Yeah, hi, my name is George Florovsky. In university, I was trained as an economist. I'm also a law school dropout, but then professionally, I became a data scientist. And from very early on, I've been a Haskell enthusiast. In fact, nice. I found out about Cardano from the Haskell subreddit.
Cool.
And the reason why I dove into Cardano was like, oh, there's a blockchain project that uses Haskell. And, that kind of drew me in. And I think, a lot of really smart people are being drawn into Cardano because it's using, really interesting kind of functional languages and, all those various cool properties. It's just fun to program in. Anyway, so I'm a Plutus pioneer, first cohort. So I signed up almost immediately as soon as Charles announced that, oh, we're gonna open up for registration for Plutus, you know, and you can sign up, and you know, if you're lucky, you get in. So I got in, I think, beginning of May, first week of May was when I started being active. And to your question about concurrency, I ran across it on the first week.
Yeah.
So week one, the week one exercise, or it wasn't an exercise, it was basically, so week one of Plutus Pioneers, there wasn't like a homework problem, but there was an example that Lars had posted of kind of like a basic naive Uniswap kind of, you know, like an example of Uniswap implemented in Plutus. And, you know, Lars was the first one to admit that, you know, it was a basic just kind of example for people to see an end-to-end kind of application, or just like, you know, all the things kind of built. Yeah. So almost immediately when I started poking around with it in the playground, I noticed that, okay, it's nice when we do it the way Lars shows in his YouTube video, where, you know, Alice does something and then he inserts a pause for one slot, and then Bob does something, pause for one slot, Charlie does something, pause for one slot, right? But as soon as more than one of them does something, then the results don't make any sense. I'm not sure if I ran across into it because I forgot to put in a pause, or whether I intentionally did it, but regardless, I very quickly came across a situation where, you know, 3 people put in simultaneous bids, and the bid that won is completely arbitrary, right? And that was determined by the, you know, the Plutus Playground kind of internal code. When I thought about it a little bit deeper, you know, that night, I realized that on the blockchain, it would essentially be whose pending transaction would be first to show up in a block, you know, from the mempool, right? So, yeah, so that was my first exposure to UTXO contention from the very get-go of the Plutus Pioneers program. And if you look in the Discord chat, you can see it right up there, like in a week one. You know, myself and a few other Plutus Pioneers started kind of brainstorming on, like, what can we do about this? So to answer your question, the concurrency issue has not been a surprise for the pioneers. You know, in the September timeframe, it was a little bit of surprise for me and a lot of the pioneers in the very beginning, like in May, and we're like, wow, okay, wait a second, what do we do about this one? But yeah, so it's been on our radar from the very beginning, and we've been kind of brainstorming approaches to deal with it from the very beginning. Of course, it is a challenging problem, right? You know, I think everybody kind of admits that, and it's taken a while for the various approaches to come out to kind of try to address it. So let's talk about it. Just briefly describe it. Well, like, what's the concurrency problem on Cardano? So on Ethereum, for example, each block contains a set of transactions, but Ethereum has requires a strict order within a block of the transactions. Now, question, who gets to decide that order? The miner, hence miner extracted value and so on, right? So basically, Ethereum has a built-in concurrency mechanism, which is called miner discretion.
Yeah.
Right? So the miners can decide how to order the transactions, and then every dApp can just assume that it can be sequential. So Uniswap is a sequential dApp. It goes, you know, one by one. There's no parallelism or anything. It just goes through the transactions in whatever order the miner has decided on, and kind of and works through them, which means it doesn't have any problem with global state or anything like that. Cardano doesn't have that. Cardano doesn't have a built-in concurrency within a block solution, because establishing the order of transactions within a block is kind of arbitrary without doing, like, you know, a whole bunch of additional mechanisms. And so I guess at that stage, they hadn't developed yet a concurrency, kind of a built-in protocol level concurrency solution. I imagine we might eventually have one, just like built in. So we won't need a lot of these smart contract based concurrency solutions that a lot of the DEXs are coming up with. But for now, you know, we basically have to do it in the smart contract layer. Makes sense. Right, exactly. And essentially that's what streaming merge that we have developed at Cardax, that's what it boils down to. How do we determine a chaining order of transactions within a block, essentially, right? And we want to do it in a, to the extent possible, a deterministic way, a fair way, and an efficient way. And so what we've landed on, and I guess I'm jumping right into the meat of the, of the article.
Feel free.
That prompted
Make
this
my job
interview.
easy.
Yeah, exactly. So what we've decided, if we step back a second, if you're an off-chain observer of the blockchain, there, and you have global awareness of the entire blockchain, you don't have any problem, figuring out a way to sequence transactions, because what you can do is you can just observe, different people posting their orders or whatever on the blockchain, and see, how they're ordered over time. So, these transactions made it into this block, those transactions made it to the next block, and so on. So at least you can, that, temporal order. So these after those, right? Or before those. And then you can take a look at any of the simultaneous kind of actions, and you can figure out a fair way to order them. So initially, we thought that maybe we don't have to order them at all. Maybe we can figure out a way to just create a dApp that is able to handle simultaneous orders just natively, right? Via some sort of averaging mechanism. So that was kind of our initial design. But we quickly realized that for a wide class of dApps, that's not feasible, because you run into edge cases and in situations where you can't satisfy all the simultaneous orders. Some unless you decide on some kind of way to partially satisfy them, but that's not desirable either, because that means you start accumulating this state of like unfulfilled orders or partially fulfilled orders on the blockchain, and it just becomes, it snowballs on you. So what we've decided to do instead was kind of a fair random permutation of the simultaneous orders. So we have various sources of entropy, or kind of random seed, coming out from various independent sources. So whether from the users themselves, the UTXO hashes, we can also inject kind of additional randomness in.
From external?
Yeah, either from external or, exactly, from external, but also in a kind of in a fair deterministic kind of way, right? And the idea there is that we want the randomness to be non-exploitable and to be kind of, actually random and fair, right? So that's kind of like the design goal there. We're going to be publishing a more in-depth article about how we're handling the randomness, but like in terms of the design goals, that's what we're aiming for. So we're aiming for like a good randomization, so that we can do fair permutations of the orders, or of the simultaneous orders. Otherwise, though, like in terms of the time order, that stuff is basically what the rest of this, like that's what the streaming merge article was about. How do we figure out the timing of orders? So I started this out by saying that if you're an off-chain observer, this is very easy to do, because you have global awareness of the entire blockchain, and you can just like pick out the subset of the blockchain that you care about, like the traders, and just observe them declaring their swap orders or whatever other actions they want to do, and then you can just sequence them over time. Unfortunately, that's not possible to do directly with plutus, or the extended UTXO model, because the extended UTXO model, in each transaction, you have to explicitly include all the information that is accessible to that transaction. There are no implicit dependencies. You have to be explicit about what makes it in. And furthermore, the stuff that you bring into the transaction must fit within the transaction size limit, the block size limits, the execution limits, the memory limits, all those various blockchain limits that make sure that the blockchain can keep chugging along without its resources being exhausted. So the way that we are approaching that then is we have a process by which we assign exclusive lanes to our users, so the liquidity providers, the traders, and within each exclusive lane, each person can simply submit their orders or their actions, without any interference from anyone else, because they have exclusive access to that lane. And then we break up time into cycles. So the actors that the owners of the exclusive lane or like the exclusive thread, can submit orders within the active cycle. And then once the cycle elapses, they move on to the next one and they can keep submitting there. But for the elapsed cycles, we can start merging them in together, right? Mm-hmm. And the really critical point is that the merge transaction is deterministic. Deterministic in the sense that there is only one way in which it can be resolved.
Right.
Now, it seems paradoxical because I was just talking about randomness, and randomness is non-deterministic. But the point is, by the time the merge transaction goes through, all the randomness already exists. Like all the sources of randomness have already been kind of pinned down or like committed, like fixed, right? So by the time the merge transaction is submitted, there's only one way it can go, which means there's no room for discretion during the merge process. And we felt this is very important because we want to make sure that the third parties that are facilitating the protocol don't have any room to wiggle in terms of figuring out which users go first or whatever, like various, prioritizing users or, in a potentially unfair way. Other DEXs have approached this in a different way. They've decided to use kind of incentives to kind of ensure that the third parties, pick the optimal order or the fairest order of transactions. We are trying to pin it down with the smart contract logic itself. Right. So that's the streaming merge approach in a nutshell.
Wow, it's really cool. And this is, I haven't done any pre-reading on this, right? So I'm figuring this out in my head as we go live here, like everyone else who's watching. So, from the way that I understand it, and I'll ask maybe clarifying questions, or you can tell me if the way that I'm viewing this is correct or not. You have Ethereum that you mentioned. You have this sort of single stream, right? You have canonical ordering determined by...
It's not canonical. It's... Oh, yeah. It's basically...
determined
it's an order
by
determined by miners. Yeah, exactly.
Yeah, which becomes canonical after that.
Right.
Basically,
right.
Yeah. And so then from there, you compare that to the way that you're approaching this in Cardano based on these completely different protocol level structures in general. And so what you're doing is you're basically parallelizing what's going on for inputs into this DEX. You're parallelizing them into lanes, and then on some sort of cadence ordered by randomness, you're then aggregating those into a finality transaction, if you will, that gets consummated.
Yeah, and to be more specific, think of it as merge sort. Mm-hmm. Right. So we have we start with multiple parallel kind of lists, right?
Yep.
And we do we're basically doing a merge sort on those lists based on time, right? So earliest gets in first, and then but like with merge sort, usually when it hits on a tie, it's going to pick the element from the first list and then the one from the second list. Instead of doing that, we just randomize which one it picks. Right, so it's merge sort. It's like a maximally unstable merge sort, if you think about it. With more than two lists being merged at a time. Like we're merging multiple lists, like multiple lanes being merged at the same time. But you could think of it as a maximally unstable merge sort for the algorithm geeks out there.
Yeah, you need to put that on a T-shirt, guys. No joke.
Yeah,
Cardax.
Yeah, the maximally unstable merge sort. Yeah.
Yeah, no, that's awesome. So then, as you were talking through this, the other thing that I noticed is, the parallels in some ways to the approach from like a purely fundamental perspective to how the Cardano team approached the design of the underlying blockchain and the way that the proof of stake and the layers beneath actually function. Randomness is very important to the way that the whole Ouroboros protocol works underneath the hood. So I thought that was interesting. Of course, there's a lot of differences, but there are some similarities that I wanted to point to. Yeah,
I think so. In the blockchain, the main purpose of randomness is for fairness, right? Yep. If you think about what is a blockchain in the first place, a blockchain is just a way to if you and I we have an interaction, a kind of an ongoing interaction. Traditionally, we'd get some third party to mediate it, and we'd give away a whole bunch of our power over our interaction to the third party. What blockchain does is it breaks our interactions into bite-sized pieces, and then it outsources the kind of the third-party mediation of it to a large pool of validators that are sampled from randomly for each bite-sized interaction. So the randomness there is what ensures the fairness and between our interaction, because none of the validators has too much power because they are being randomly chosen and they don't know. Similarly, for Cardax, we are using randomness to ensure fairness and non-exploitability, because any of the people submitting the actions, they don't know if they end up being in a simultaneous block of transactions with someone else. They don't know if they will be before or after the other transaction, which means they can't guarantee that they can sandwich attack, someone else, because they might end up on the receiving end of that. Actually, right. So that's kind of the idea why we want randomness. Usually, where you want to create some sort of fairness, I think in a decentralized kind of protocol, randomness is probably the way to go.
I'm right there with you. Randomness is a very magical thing. People maybe don't fully appreciate it, but it's behind a lot of the things that you use on a day-to-day basis, particularly if you're in the crypto space or the blockchain space, whatever you'd like to call it. Now, George, I really appreciate you explaining all of that, because I think for people that are watching or that are listening to this, having the ability now to compare this to other solutions that have been proposed by other projects is probably a great thought exercise. And Ryan, I want to bring it back to you. I know you've been patiently listening as well. I appreciate that. For Cardax, what is the sort of what is the next step where we're sitting here middle to end of December? What can folks look forward to and to seeing from the project here in the next maybe the first quarter of 2022?
So we're aiming for first quarter of 2022 to go live towards the end part of Q1. But yeah, as in everything, there are a lot of things that need to happen, and so everything needs to happen on time, and there are some things also that don't depend on us. But just to give you an idea, we're working now with also external teams, with teams from M Labs, also the guys from World Type as well, who are writing now the formal spec. And then the guys of M Labs are also helping us in ramping up the Plutus code. With that also, then we need to time well the external audit. And all of those things, we have to just put it in a short period of time and make everything be on time. If any of those steps take a little bit longer, the whole thing takes longer. But we're aiming, to your question, for Q1 towards the end of Q1 to go live with the MVP of the DEX.
That's awesome. Yeah, no, I know there's a lot of stuff that has to happen, and I think of anyone, folks in the Cardano space are probably the ones that will understand that it's better to do things right than do things fast. So that makes perfect sense, without a doubt. Now, George, from your perspective, and answer this however you'd like. What has your experience been, if you could sum it up, right, as a developer who had worked with Haskell and worked in data science and other areas of the technology world first, now coming into this space and building on Cardano? If you could give folks, an idea of what it's been like and what your honest take has been, that would be cool.
Yeah, it's been great. I've been having fun the whole time. It's really interesting working in this space right now, because a lot of these fundamental questions are still being resolved. And on the one hand, the tooling, the libraries aren't in place, but on the other hand, if you find it fun building those things and figuring out those things that eventually will be used by potentially hundreds or thousands of dApps or something, then it's an exciting time to be involved. So I've enjoyed participating in the Plutus program, and then I was in the blue, white, and purple Alonzo testnets, you know, and then I dove into the Cardax project, and it's been kind of nonstop, you know, Plutus development the whole time. And it's really great collaborating with the other, you know, Plutus developers here. A lot of them are very humble and very collaborative, and everybody's just trying to solve these problems, and kind of we help each other out, and yeah, so it's been a great experience for sure.
That's awesome. Yeah, I'm sure everyone wants to know, you know, what it's really like. And there are, you know, relative to other spaces right now, it's still very early in the Cardano world, and there are a lot fewer developers, or maybe just a lot fewer that are public and often engaging with the community. So it's always interesting for folks to hear anecdotal stories about those who are building in this space. So last thing I wanted to ask, and you know, both of you can answer this question however you'd like, but where can folks get engaged with Cardax more deeply? Maybe Ryan, you can touch on areas where folks can get involved, like from the perspective of like users and, you know, understanding more about the project functionally, and then George, maybe for the technical folks that like to dive into the nuts and bolts deeper, where there are options there.
Sure. So to know about Cardax, I guess the best place to go is to our website, cardax.io. From there, usually all the discussions happen in our Discord. You'll be able to also to find the link there. Follow us on Twitter as well, Cardax DEX. But mainly where we have all the discussions with our community is on Discord. We have now like roughly 15,000 members. And we do also AMAs with them, and we keep them informed on a weekly basis as well on what have we been doing that particular week. So then, because things take long, we also want to tell everybody in our community that it's not that we have been just home watching TV, that we have done a lot of things during that week, but they don't not necessarily have to know exactly what, but I tell them on every Friday on an update, and also we do a tech update on our blog to tell everybody what we have been up to. And one thing also that for your viewers or listeners that now that I was talking about the blog, if you want to see the article that talks about the streaming merge that George just mentioned, you can just go to our website, cardax.io, just click on blog, and then you'll be able to read the full article with diagrams and everything there. And yeah, maybe we can put it also in if you allow us in the description in YouTube, so then folks can check it out as well for themselves.
Yeah, you know the YouTube game.
Yeah, I would say right now, in terms of like the more technically minded folks, for now, I think the main way for them to see what's going on with Cardax is these kind of more in-depth pieces that we are posting on our blog. By the way, that article is not the entire; it's the beginning of a series. So in the article, I explained kind of the very core aspects of the streaming merge, the part that kind of talks about that whole merge sort aspect. I've left for future articles the randomization part, and also in terms of how do users get these exclusive lanes, transfer them to other people, relinquish them, so on. Right. So this is going to be an ongoing kind of series of technical blogs of a similar kind of depth, technical depth. And I try to get into as much detail as possible without kind of harming the exposition. So yes. In terms of kind of more back and forth interaction, I mean, yeah, you can post comments on the article, and some of the devs, like, we occasionally like take a look at them, and we'll have some back and forth, or like on the Reddit or on the Discord or something. But I think for now, at least, because we have this kind of launch target, most of the devs are really busy just building the thing.
Heads down.
Right? Yeah, it's kind of heads down right now. But I think once we kind of have it out, and when it's out, it'll actually be out, and people will be able to see the implementation itself, more closely. Then, of course, we would welcome, collaboration and open discussion and everything. pull requests, whatever.
Yeah.
So but for now, I think generally it's just via the blog posts, I would say.
Excellent. So yeah, I will link those up, and folks, make sure you bookmark if you're interested in following what's going on. There's going to be more posts there, and so you'll have that link if you need it. Most of all, thank you so much, Ryan and George, for taking the time to talk about Cardax, the concurrency solution, how folks can engage. I think it was great. So yeah, no doubt. Really, thank you so much for being here.
Yeah, thank
you, Hashoshi, for having us.
Inviting us.
Awesome. And everyone who's watching, thank you as well for taking the time. Hope you got something out of this deep dive conversation. And until next time, cheers.
Cheers.